Hello everyone, Dr. Alex Vasquez here, and I'm going to provide you some information and some insights from this presentation that I'm still working on. I'm going to record this rather quickly and hopefully not have to make any edits to it because edits actually take more time than the recording itself. Usually an hour of edits per 1 minute of video in my recent experience. And also, my last caveat is that I'm not in my recording studio, so we may have a little bit of echo or background noise. But again, I'm just trying to provide some information, obviously, from a presentation that's kind of in process right now. So, the theme of this presentation, which is a brand new presentation, I'm also recording it with different software, brand new software. The theme of this particular presentation is the gut-brain connection. And so what I want to do right now is talk about gut-brain and focus on some neuroinflammatory pathways that are specifically induced by gastrointestinal dysbiosis. So a few of these slides we're not going to focus on. I'm just trying to show you some context on our way to talking about some specific neuroinflammatory components of the gut-brain connection. So when we talk about gut-brain connection, these are the conditions, the clinical conditions, where we really see the gut-brain connection shine. So let's just go through this quick list. Depression, anxiety, and any type of quote-unquote stress, brain injury, stroke, also obviously that would be a form of stress, autism, schizophrenia, so kind of neuropsychiatric conditions, neurodegeneration, Alzheimer's, Parkinson's disease, those would be neurologic conditions, hyperphagia, obesity, insulin resistance. I'm still working on developing some of these, that's why I don't have the entire presentation finished. Multiple sclerosis recently got a lot of new data just published this past month supporting the gut-brain and dysbiosis connection there. PANDAS and pediatric obsessive compulsive disorder is also getting a really strong boost in the research lately. Brainstem encephalitis, migraine headaches, and amplified pain conditions and fatigue conditions such as fibromyalgia, complex regional pain syndrome, and chronic fatigue syndrome, again, which has recently been renamed systemic exertion intolerance disease. So I've been working on this information now for several years. I first published this model of dysbiosis-induced fatigue and pain back in 2008 when I was commissioned to write this book for the Institute for Functional Medicine. And just in this year, 2016, I've really advanced that model a lot, and I've come to a better understanding of it. You know, obviously, 8 years ago, I didn't understand as much as I do now. And even in this past year, I've kind of had a quantum leap in my understanding of neuroinflammation. Obviously, I published some updated models in the books and the monographs and in some peer-reviewed research as well. Some of this is highly irrelevant, so we're just going to skip past it. I'll focus in on the parts that are most important. But, you know, we could talk about gut-brain connection all day long. That's mostly a concept. We have to ultimately translate that concept into ideas that we can actually work with, and then how to translate those ideas into clinical actions. That's the purpose of this presentation. And as you could expect, that's a difficult process. That doesn't just happen immediately and easily. So a lot of these early slides in the presentation kind of set the conceptual framework for that conversation. And here's where we start to get into some action about how to understand and explain and therefore treat these components of the gut-brain connection. Ultimately, we have to take that idea, we have to take that concept and start to assign molecules and pathways to it so that we can eventually understand what we're talking about. And ultimately, I think what we're talking about here is neuroinflammation, certain neurotoxic metabolites, which I'll focus on in this brief introduction, and then also some ways that lifestyle kind of initiates that cascade. And the biggest examples that we have are stress counteracted by relaxation. So the dynamic duo here, let's say, that we're going to focus on is neuroinflammation, and decoding and deciphering what that actually means, and also looking at specific metabolites. Now, previously I was focusing on metabolites created by microbes, but in this presentation you'll see that we have to talk about metabolites that are created within the human body by the human body as a result of the inflammation induced by gastrointestinal dysbiosis. And as I say here, everything else stems from these core components. So let's focus on neuroinflammation and endogenous and microbial metabolites. I think that's where the action is. So neuroinflammation, of course, is brain inflammation. That's the more casual way to talk about it. That includes glial activation, astrocyte activation, systemic inflammation, induction of a pro-inflammatory phenotype. I've been talking about that since 2012, actually since 2011. If entry of pro-inflammatory immunocytes into the brain, basically. So peripheral inflammatory cells can, in contrast to what we thought before, but we know now, they can enter into the brain, and that contributes to some of the inflammation, for example, that we see with HIV and also with multiple sclerosis. We're all aware now, I believe, that the vagus nerve provides an anti-inflammatory effect. Obviously, if that pathway is, let's say, blocked or triggered by pro-inflammatory stimulus, then either we're going to be deprived of the vagal nerve anti-inflammatory effect, or perhaps the vagus nerve could actually create inflammation instead of creating an anti-inflammatory effect. Another pathway that gets involved here is this pathway called brain-derived neurotrophic factor. Generally speaking, this is an anti-inflammatory pathway. However, we do see elevations of BDNF in patients with fibromyalgia, migraine headaches also, I believe, and autism. So in some people, this pathway isn't activated sufficiently, and they suffer because they don't have enough neurotropic effect or brain building effect. In some conditions that are kind of excessively inflammatory, we again see an elevation of BDNF, and that's because it's either compensatory or actually harmful. I'll talk about that more by the time I get the presentation finished. Again, microbial metabolites is what I had been focusing on previously, but in this conversation we're going to focus on endogenous metabolites that are created, especially through tryptophan degradation, and how those can actually promote more neuroinflammation. So here's a diagram that I made recently discussing the gut-brain connection. When we talk about gut-brain connection, we have to talk about, well, what are the actual connections? And those include the vagus nerve, as you can see here. Let me back up just a little bit. You can see the vagus nerve here, and also the blood-borne metabolites, for example, from the gut that ultimately affect the function of the brain. Also the inflammatory cells that can influence brain function or enter into the brain and cause direct damage. So again, here's the model that I've been creating lately, and then here are some of the clinical applications. So neuroautoimmunity, obsessive compulsive disorder, especially in kids, PANDAS obviously in kids, autism mostly in kids, irritable bowel syndrome, depression, hypertension, depression, pain, depression again, hypertension, cardiometabolic disorders, obesity, chronic fatigue syndrome, depression, hypertension, cardiometabolic, diabetes again here, fibromyalgia, all pain conditions, autism, obesity, diabetes, schizophrenia, and again cardiometabolic syndrome and depression and autism. So we're seeing a lot of clinical applications of this model. We, as researchers, doctors, clinicians, I think are still trying to understand this, and that's obviously what I'm trying to do through the development of this presentation, all of the background work that goes into that, and ultimately what can we do with this concept of gut-brain connection? What are the pathways? How do the pathways differ in different conditions? And ultimately, what do we do about that? How can we treat it effectively? So blood-borne molecules, short-chain fatty acids, acetate